Okay, so now we're going to start with the 6 checks. And we're going to do checks 1 through 3 first. They're basically all put together into one little section for us in the lab. So we need to look at the values and decide which variables we want to keep, see their effects when we rerun the analysis, and then if we need to add them back in or move on to the next variable. For example, we're going to look at this variable here. The first check we have is probability. Is the probability near 0? That's our first check. We want it to be as small as possible, but 0.4 is acceptable. Well, we've got 0.998. So that's a no on that. It's not near 0. It's almost 1. The variance influence factor, we want a value of 7.5 or lower. Is its VIF 7.5 or lower? No. So far this is a candidate for removal. So let's go to the coefficient over here. Remember, the coefficient near 0 has a slope of basically 0, which means that there's little relationship between this variable and amongst all the others on this model. This is, again, the answer is no. Depending on what the variable is it something that you think should have some sort of effect, in your opinion? Do you think that this variable, in your mind, would play a role? If it does, leave it in and go to the next one, even though these values are this way, because these will change once you remove another variable. Again, we want to approach these from a holistic point. Before we start really looking at which variables play what, we're going to remove them one by one and see how it affects all the variables as a whole. So it seems like we're focusing on one variable, but really we're looking at what removing a variable, at least at this point, what removing a variable is going to, how it's going to affect the probability of all the other variables, their redundancy among each other, and their coefficients. These numbers will change, sometimes very drastically, based on something you remove. Something that wasn't statistically significant before will suddenly be, by removing a variable you may not even realize is related to it. So this is why we want to look at everything as a whole and not focus on, again, one variable trying to explain all of these. If you could do that, then really what the smart thing to do is to include none of these and go one by one and adding them in. But that's not what we're doing. There's multiple variables that are going to explain. And in this case, we're looking for 5 to 10 variables from this group of 31. This will be different for every single person. You're going to probably run this tool anywhere from 20 to even 50 times, adding in, taking away, seeing the relationship and how they change. So we got to remove some variables, but which ones? That's what you're going to do. And so it takes a lot of patience, but once you start getting it narrowed down quite a bit, once you start getting it to that 5 to 10 range, you'll see that, okay, now we got to really focus on which one is really playing a role here, or should I add more back in? So how do you compare between the two? So we've run these checks. Let's say whatever this variable is, we remove it. And there's a reason why I'm not showing you these variables. It's because you are going to be the one that decides which variables stay and which variables go. Again, there's no wrong answer. We're not saying that if you don't have these 5, that it's wrong. You just have to be able to explain it and give some sort of explanation as to why those 5 to 10 variables are the ones you chose. That's what we're looking for. A lot of people get hung up on which are the 5 to 10 that I need. It's whatever 5 to 10 that you find are the best at explaining the relationship between these independent variables and this dependent variable. I know I keep saying that, but I just want to make sure that's clear. That we're going to start off with a holistic approach, look how they all influence each other. So those are the first 3 checks. Checking the probability, checking the variance influence factor, the VIF, and then the coefficient. And even if those are all really crazy numbers, but you're like, I really feel like, whatever the variable you're looking at, I feel like this will play a role, then leave it in. And if you take it out and everything changes quite a bit, and it's for the positive, all your probabilities go down, your VIF goes down, your coefficients are higher, or really, they're extreme values, then that one clearly was causing an issue with the model. It was good that you took it out, even if you thought it had something to do with it. The 5 to 10 variables you choose may not be somebody else's, and that's fine. It just you have to be able to explain it. That's what we're looking for. So I think this first variable is not important, and it fails all the checks, so let's rerun it. How do you rerun it? The quickest way to do this is to go to the ordinary least squares. You remember we saw that messages? Just click on the ordinary least squares, and there you go. It opens the tool right back up to exactly the settings you had it. So then you just have to uncheck or check the explanatory variables that you have. You're going to be overwriting your output feature class and all the tables that are made. You're going to be overwriting those. You can still access the previous ones because they're saved in memory, but as far as the tables in your geodatabase or the feature classes in your geodatabase, those will be overwritten. So if I run this, this will actually overwrite the other ones, and that's how you rerun it. That's how you just rerun it. You should go to the last one you ran in the current session, double click on that, and then check or uncheck what you need and don't need, and run it again. And you'll get this output here. This is the one we just ran. Right click on the view,